All right, hello, good afternoon, fourth period. I think there are some of you that might need to remember to try to get this done, because I'm about to go over the problems that you should have already submitted, and I only have about 3 people that have done so, 3 or 4. I'm going over it, which kind of defeats the purpose now. I mean, of course, if you are just completely lost, then yes, this is good. If you just didn't try it, this isn't as good, and we need to try to do a little bit better going forward, okay? But I understand there are other circumstances. I hope y'all aren't having to work more than you typically do, but I have a feeling that might be the case as well. Okay, so I'm going to go over the 3 problems from yesterday, and then I'm going to give you 3 more problems. Instead of just jumping on to the last 2 type of functions, I thought it'd be beneficial for us to practice 3 more so I can give you feedback 1 more time, and then we'll move on to the last 2 graphs, which are tangent and cotangent, excuse me. All right, so I'm going to look at this number 5, and I'm going to say the amplitude is really none. Remember how we talked about that yesterday? It's always going to be amplitude, but the quote-unquote amplitude is going to help me know the vertical either stretch or shrink. And in this case, because our A, is greater than 1, I did not turn on my do not disturb, it's a vertical stretch. Does that make sense? So we should go up to 5. Okay. All right, then our period is going to be 2 pi divided by b, and our b is 3 in this case. Okay, now this is where some of y'all had some issues, okay? So I know why the issue is there. It's because some of you don't have a calculator, so I'm going to write it again. So you take the period, the 4th tick mark, and you're going to divide it by 4. So dividing by 4 is like keep, change, flip. So 2 pi over 3 times 1/4, which will give me 2 pi over 12. And then that can simplify because 2 over 12, 2 goes into both of those, which is how I get pi over 6. Now, y'all with the Casio calculator, that should not be an issue. You should just be able to do it really quickly. But a lot of y'all, if you're doing this by hand, it takes a little bit more effort. All right, so I'm going to do the next one. To get the 2nd tick mark, we're going to take the period and we're going to divide it by 2. So keep, change, flip means we're going to get 2 pi over 6. And again, that can reduce. So 2 pi over 6 is pi over 3. And again, those of you with the Casio, you don't even have to worry about it. And then for the 3rd tick mark, so let me write this down. This is for the 1st tick. This is for the 2nd tick. And this is for the 3rd tick. We're going to take the 1st tick, which is pi over 6, and we're going to times it by 3 and put it over 1. So that's 3 pi over 6. And that, again, reduces to pi over 2. Okay, so that's just kind of a refresher. And y'all, if I went fast, just slow down the video, pause it, go back, okay? All right, so now I'm going to think about secant is the reciprocal of cosine. And cosine, you remember, starts up at the amplitude, so that's what we're going to do here. So it's going to start up at 5. And then every other mark is going to be an asymptote, all right? So here's my next mark. It's an asymptote. So I'm going to skip one. The next one is an asymptote. Does that make sense? I hope so. I really hope you're nodding along with me. All right, so then this one is an asymptote. Skip one. The next one is an asymptote. And then we just have to fill everything in. So do y'all see how I kind of thought through that? I thought I had kind of reviewed my information I know about cosine, that it starts up. And then I just got my asymptote set. And you guys, the asymptotes will always be like that every other one, okay? And so then if you think about what cosine does, it makes a W. So it goes down on both sides. So we're going to go down on both sides here. And then we have to go back up on the other ones. And then we just make our parabolas. And we're done. I'll make it sound easy. It's not necessarily the easiest thing, okay? All right, so That is what yours should look like. I saw several people with the correct answers, but we got to make sure that we're careful about labeling the tick marks and then putting the asymptotes. All right, I'm going to move on to 6. If you need to go back, you certainly can. All right, so the amplitude is none, but the quote-unquote amp is going to be 1, which is no change. Okay, from the parent function, that is. And then our period is 2 pi over b, and our b is 1, so it's just 2 pi. Is everybody clear? It's an imaginary 1 here, and there's an imaginary 1 here. But I should make it in really, really pretty bold color, that means there's a reflection. Okay, so let's don't forget that. So really nothing has changed. This is like the parent function, only we have reflected it. So 2 pi, pi over 2, 3 pi over 2. Like I said yesterday, I think y'all pretty much have these memorized. All right, so I'm going to think it's the reciprocal of, if I have a C for cosecant, I need a S for sine. So sine starts at the origin, but are we allowed to do that here? No, because we talked about yesterday that anything that had a point at 0 now has an asymptote, okay? So we're going to put an asymptote there, and then we're going to go every other. So cosecant has the asymptotes like on the axis and then at the very ends of the graph. Now, to do the reflection, if you think about sine, it goes up on the right and down on the left, okay? But that's typical, all right? That's like your typical graph, your original graph. But this has been reflected, so we have to do the opposite, okay? So what was up, let's use a different color. Let's use the pink, okay? Instead of going up on the right, we want to go down on the right. And instead of going down on the left, we want to go up on the left. Does everybody kind of get that? All right. And then we're going to go up and then down. Okay, so again, pause. Oh, you know what? I almost messed up. Don't forget to label these your y-axis numbers. Did I do it on the previous one? Yes. That's something that we haven't been in the best habit of doing, so make sure that you remember to, label. Let me highlight them. This number and this number, okay? And then same thing here, because that's your quote-unquote amplitude. All right, now let's talk about the last one. Our amplitude is none. Our quote-unquote amplitude is 1, which means there's no change. Okay, and then our period is going to be 2 pi divided by, and this is where you got to remember that it's this thing right here, which is 1/4. Okay, so that's 2 pi times 4 over 1, which is 8 pi. Does everybody kind of see what I did there? I did keep, change, flip, and I flipped the 1/4. That was something that we always kind of struggled with, so I just wanted to be careful to explain that. Does anybody have questions about that? You might hear a talking baby in the background. He's waking up from his nap. So, yeah, let's talk about how to get the first tick mark. So we're going to take 8 pi and we're going to divide it by 4. You don't have to worry about keep, change, flip here because that actually divides nicely, which is 2 pi. Okay. To get the second tick mark, we're going to take our period, which is 8 pi, and we're going to divide it by 2, which gives me 4 pi. And then I think y'all are good with like 2, 4, 6, 8. Who do we appreciate? So I think y'all are probably okay, but to get the third one, we're going to times the first one by 3. Okay? And so now we can put in our asymptotes. So secant, let me get a different color. Secant is the reciprocal, I cannot spell, is that right? That doesn't look right. Reciprocal, yeah, I guess it is. Okay, reciprocal of, if we have a S, we need a C, so it's the reciprocal of cosine. Cosine starts up. We don't have a reflection here, so we can still start up at the amplitude. And then I'm going to put in my asymptotes, every other one. And then I'm going to remember what cosine does. So it starts up and then it goes down on both sides. And then it has to go back up. Do y'all remember how we talked about, I don't remember if I said this yesterday or not. When we first learned sine and cosine, I always said like this last point, this right here. Oops, I didn't mean to do that. I meant to get a highlighter. This point here and this point here, the last point you make on either side should be in the same location as your first one here. So that's also just a way to kind of check yourself. It also happens over here. Well, okay, I lie. It doesn't, because your asymptotes are on the middle and the end. But it does here as well. So the first one you make and then the last one. So that's for secant. Okay, so I hope that has helped a little bit with those graphs. I'm going to give you one more chance today to do 3 more graphs just for some feedback before we move on. So here are the 3 that I want you to do. Notice that we got some reflections, some with period changes. We're really honestly not going to go much more in depth than that with phase shift and vertical shift because it gets kind of complicated. So especially with distance learning, that's going to be very tough to explain. So we're going to do this today, and then tomorrow we will move on to tangent and cotangent. All right? So let me know if y'all need anything. If I can do anything differently, let me know. If I can explain something a different way, just send me a text or an email. And please don't forget to send me yesterday's, whatever numbers those were, that I just went through, 5, 6, and 7. So you should have no excuse about getting them done now. And so now you need, if you haven't already sent it, you need to send me 8 through 10 as well. Happy St. Patrick's Day. Hope you're wearing green. I'm not. I need to be pinched. All right. Talk to you later. Bye-bye.